Hey everyone, my name is Pranav Sharma and today in this video we will be learning how to calculate the time period of a pendulum. You might be aware about the time period of a pendulum, but let me explain it to you again so that you could revise it. Suppose we have a pendulum. It is held with the roof with a spring. So the time taken by this pendulum to move from this position to this position and back to this position is called the time period of the pendulum. And this whole is part is called one oscillation. In short, we can say that the time taken by the bob of the pendulum to complete one oscillation is called the time period of the pendulum. And this position from where we are releasing the pendulum is called as extreme position. Why is it called extreme position? Because suppose we are releasing the bob of the pendulum from here, then it will move here, and when it will return, it will not be able to cross this, it will not be able to move further from this position because of the conservation of energy, and it will maximally go to this position. It will extremely go till this position only. That's why this is called the extreme position of the pendulum. So now in this video we will be learning how to calculate the time period of a pendulum. Suppose we have a pendulum in which the mass of the bob is m and the length of the spring is L. Then the time period of this pendulum will be 2 pi times root L by G. In this equation, L is the length of this spring, pi is obviously you can take it as 3.14 or 22 upon 7, both are correct, but I'll prefer you to take it as 22 upon 7 because it is the most common value of pi. And here G is the famous gravitational acceleration, which is 9.80 meter per second. Why I wrote it as 9.80 meter per second? Because when we fall an object from any height, then every second it accelerates with a velocity of 9.80 meter per second. That's why it is written as 9.80 meter per second, or in short we can write it as 9.80 meter per second square. And when you will apply all the values in this equation, you will get the time period of the pendulum. And in this equation you can observe that we are not considering the mass of this bob, and this clearly means that the mass of the bob doesn't decide the time period of the pendulum unless we change it the length of the string. Suppose here we take the mass of the bob as 10 m, then still the bob will take the same time period to complete one oscillation. And suppose we change the extreme position of the pendulum. We release the pendulum from here and then it moves from here to here and then back to here. Then still it will take the same time to go from position 3 to position 4 as it took from moving to position 1 to position 2. You can write it like time taken by bob to move from position 1 to position 2 is equal to time taken from for the bob to move from position 3 to position 4. And these two things means that the mass of the bulb or the extreme position of the bulb doesn't decide the time period or doesn't affect the time period of the pendulum unless we change the length of this spring. So now we will be doing an experiment to understand this this formula more clearly. And in this equation, in that experiment, we will be taking the value of L as 1 meter. And when we take the value of L as 1 meter, then we get the time period of the pendulum as 1.9 something seconds, or in short we can write it as 2 seconds. This means that if there is a pendulum in which the length of the string is 1 meter, then the time period of the pendulum will be approximately 2 seconds. And in that experiment, we will be counting 10 oscillations. And according to our equations, if we take 2 seconds for one oscillations, then it will take 2 into 10 seconds for one oscillations, or it will take 20 seconds for one oscillation. So let's move to the experiment. So here I have tried to explain you the equation of t equal to 2 pi times root L by G by making a pendulum. And in this pendulum, this lock is the bulb and the length of this string is approximately 1 meter. And in this experiment, I will prove to you that this bob of the pendulum will take 20 seconds for 10 oscillations. So let's do the experiment. I am releasing the bulb from here and let's see, will it take 20 seconds for 10 oscillations or not. 3, 2, 1, go. 1 oscillation, 2 oscillations, 3 oscillations, 4 oscillations, 5 oscillations, 6 oscillations, 7 oscillations, 8 oscillations, 9 oscillations, and 10 oscillations. And you can see that it took 20 seconds for 10 oscillations. It didn't take exactly 20 seconds because I think my reaction time is slow, or it can also be that the length of this string is 0.99 or 0.01 meter. And in the equation we also found that when we take the string of length 1 meter, then the t's value is 1.9 something, and we took it approximately as 2 seconds, and the difference is made by these 4-5 reasons only. And now I am increasing the mass of this bulb by sticking a magnet with it. And let's see, will it still take exactly 20 seconds for 10 oscillations or not. Let's do it. 3, 2, 1, go. 1 oscillation, 2 oscillations, 3 oscillations, 4 oscillations, 5 oscillations, 6 oscillations, 7 oscillations, 8 oscillations, 9 oscillations, and 10 oscillations. And you can still see that it still took 20 seconds for 10 oscillations, and this experiment proves it completely that the equation of t equal to 2 pi times root L by G is absolutely correct, and this video proves that physics works.